When you are giving the question, the first thing, go and read the requirements first. We are dealing with what is called, we are working on what is called multiple linear regression. Multiple linear regression. Hold on. Regression, okay? Okay. When giving the question, start from the bottom. Read the requirements. Yes, somebody should read it. Who is reading? Who is reading? Be quick. I have 30 minutes to finish this or less. Okay. Based on the results, this multiple linear regression. When you say we have linear regression, we have a simple one. The simple one is like saying y equals a plus bx, which you did somewhere in high school, where you learned that this is the formula. We can use this to sketch a line on a graph. We can use this to find the gradient, the slope, okay, the intercepts. Okay, so the B, I think the B is the gradient, right? Or the slope. And the A is the intercept, right? This is a simple regression. Simple regression has only one independent variable. When you say independent variable, Y here is an independent variable. X here is called dependent variable. Okay, X here is called a dependent variable. All right. But when you say a multiple linear regression, it means that we could still have one independent variable like y. We will still have the intercept, but the x, it would be multiple. That's why it's called multiple. This is a single linear regression model. But if it's a multiple, then this x will be different. So we are going to have like B0x1 or B1x1. Then we can have B2x2. Then we can have B2x3. Okay, that is it. This is multiple linear regression model because the independent variables are multiple. It's not only one, like the first one. The second one is called multiple linear regression. We still have the independent variable, we still have the intercepts, but we have x values of 1, 2, 3, different independent variables. So because the independent variable, which is the x, is more than 1, we say multiple linear regression. Guys, are we good?
Yes, sir.
Am I teaching only one person? Am I teaching only one person? Are we all good? Or you are watching the sports, the football?
No.
All right. So now let's go. Let's go to the outputs. I'm coming here. Watch. Here. I'm talking about summary outputs. That's what I'm discussing now. Summary output says regression statistics. Multiple R is called I think it's a correlation. Yeah. Then R square is called the coefficient of determination. I just said R square, standard error. Observations, the one we just did, t-test. The N stands for the observations. And then you have the standard error. Standard error is represented with B. B is for standard error. Okay, standard error is the B. This one. Then there's the observations. Then we have ANOVA. ANOVA is analysis of variation. Analysis of what? Variation. Then we have the degree of freedom. Remember we've talked about this? N minus 1. Then we have SS, MS, F. F, I'll not use this. I'm going to use this guy. Significance F. So this significance F is the probability of F. So when I write 70%, which is a percentage, what is the probability figure for 70%? It means what is the decimal fraction of 70%? 0.7. Do you get it?
Yes, sir.
Good. So what I mean by this F here, the significance F is the probability of the F. So what I'm going to use, I can use F or I can use significance F, either. But I always prefer using significance F because when I use significance F, I will not go to the table. When I use this F, I have to go to the table.
Okay.
Are you good?
Yes, sir.
I'm explaining everything here. What you need to know. I mean, what we need. Those who don't need, are not spend so much time. So we have the degree of freedom for regression, for residual. We have the SMFS. Okay. Divide, divide 1593. Divide this by this. Let me see. That is SS over MS. What do you have? I want to check something. The SS over MS. What do you have? Divide the figures. Let me see. For the regression, for the regression.
Yes, so I think it's 5.0000067.
5.00.
Yes.
Okay, that's fine. Let's continue. Then we go to, from there, so this is the first table, this is the second schedule, and this is the third schedule. So I'll be mentioning them. Okay, let's continue. Now, in the third schedule, we have the coefficients here. We have the coefficients here. We have the standard error. This standard error is for the entire work. This standard error here is for the entire work. Then the standard, they are all called parameters. Okay, they are called parameters. So the standard errors here are for each parameter. Then the standard errors here are for each parameter. Then we have the t-stats. Remember the t-stats we saw for my network is disappointing me. Don't mind it, we'll finish it. My network is disappointing me. Can you hear me?
Yes, sir.
All right. So t-stats, remember the t-stat is like the t-car, what we computed. Then the p-value. So the t-stats, its probability is a p-value. The t-stat is for each of the parameters. Its probability is the p-value. So I can use the p-value to solve, or I can use the t-stats. Or I can use the t-stats. Then the lower of 95%. So you see, if you see 95% here, you see 95% here. What do you think that the whole research should be 100%? So if you are seeing 95% here, it's talking about the confidence level. So what do you think the significance level will be?
5%.
That's it here. Watch. Are you seeing it?
Yes, sir.
So the 5 year plus the 95 will give you the research to be 100. Okay, so we are done. Let's move on. Now the question says, write down the estimated regional sales model. So A. I hope I finish before the 30. So guys, I'll speed up a bit, okay? So write down the estimated
Okay.
regional sales model. So I'll say that I will say that let's um, the regional sales be equals to what? Y estimate. Then I would say let alpha, okay? No, hold on. Let x1 be this x1. Let x1 be the number of retail outlets. Number of what? Retail outlets. So here. God, let me be quick, speedy. I have another class. This is the retail outlet. This is X1. This is X2. This is X3. This is X4. This is X5. Are you good? So
Yes, sir.
X2. Let it be what? Number of automobiles registered. So this is how you solve it. Automobiles registered. X3. Personal income. X4. Average age of what?
Automobile.
Automobiles. X5. Number of supervisors. Those of you who have not subscribed to the channel, why are you doing why are you doing that? What kind of attitude is that? You have to go and subscribe. Yo. Okay, so that's X5. So when you are done, you will say that, pay attention. We are going to write the model to pattern after this. Okay. So we'll say sales, regional sales. I hope I'll finish with time. Equals regional sales equals, right? What is the intercept? You see here we have A. This one begins with an A. This is an A. The A is the intercept here. I'm using blue. The A is the intercept here. So what is the intercept? One, is it negative?
Yes.
Negative 19 point what? 6715. Then we go to B1. B1 here is the coefficients. So the coefficients you are seeing there, they are the B1, B2, B3. They are the coefficients. So is the coefficient for the next item, is it positive or negative? The next X1 is number of retail outlets. Is it positive or negative?
Yeah.
This is the coefficient. I'm done with this. This is the next one.
Yeah.
Is it positive or negative?
Negative.
Negative
Negative.
0 point. How many zeros after? 3. 1, 2,
Three.
3. Then I'll bring what? It is multiplying this. So times x1. Are you getting it?
Okay.
Guys, do we get it?
Yes, sir.
Okay.
So this is the A. This is the A. This is x1. This is x2. This is x3. This is x4. This is x5. So when I pick the coefficients, I'll multiply by what is here. Intercept is not a variable, so I cannot multiply whatever is in. I cannot say negative 19.674715 times intercept. Intercept is a constant, it's a figure. But the next one, we are using x1 to represent number of retail outlets. So when I write this figure first, with the coefficient, I multiply by the x1. That's what I've done. Then I'll continue. X2, the figure, is it positive or negative? Positive. So plus 1 point, 1 point what?
1.99.
7399 x2. The next one, is it positive or negative? Positive. Plus 0.4099 multiplied by x3 plus 2.0357 multiplied by x4. The last one has a negative coefficient, so negative 0.0344 x what? 5. Are we good? So I've done the
Yes,
A.
sir.
I've finished with the A. This is my answer for A. It is negative 0.1236 x1. Then we go. What is the B? I have
The
24
B
minutes. B is
interprets the
what?
coefficient.
Interpret the coefficient of the model. So pay attention. It's not very difficult. As I said, you do the same thing you're following going forward. So you have to understand the concept. So interpretation, you say, you say, what is, so still, the intercept, what is alpha? Alpha equals what? Negative, alpha is the intercept or the A. Negative 19.6715. You say that when all the independent variables are zero, regional sales S. Regional sales S, just write the A, negative 19.6715. Are we okay? All things being equal. Are we okay?
Yes, sir.
Class, are we okay?
Yes,
Class,
please.
are we okay?
Yes.
Or you can say
Yes,
when there is no independent variable, or when there are no independent variables, regional sales, when there are no means what? Zero. There's nothing there. So when there are no independent variables, regional sales is, in other words, if I make x5 0, x4 0, they are the independent variables. X3 0, independent variable. X2 independent variable 0. X1 independent variable 0. When I multiply the 0.0334 times 0, what do I have? 0. 2.0357 times 0, 0. 0.4099 times 0, 0. This one to 1.7399 times 0, 0. 0.006 times 0, 0. So all those with x1, x2, x3, when they are all made 0, when I multiply all and add them, I'll get 0. So I'll be left with negative 19.6715 minus or plus 0. The final answer will be regional sales will be equal to what? Negative 19.6715. That's what I've written here. Are we good?
yes, sir.
Only one person. Only one person. Class, are we good?
Yes, sir.
Watch. Now let's move on to the next one. Now we go to what? B1. This is B1. B1 because this is X1. B1, I told you the standard B, this is called beta coefficient. If the standard error, let me correct this. The standard error, the symbol used to represent the standard error is SB. The standard error here, it is S and beta coefficient. That is called standard error. Okay, but when it's only B, like as I've written here, when it's only B, as I've written here, it is called beta coefficient. So we go. Pay attention, it's not difficult. So I've interpreted the A, right? The next one is the B. Beta coefficient 1 equals, what is the coefficient for x1? Negative 0.1236. Then we say, when, right? What does x1 stand for? Yes, what does x1 stand for? Oh,
Number of resale outlets.
number of retail outlets. So when number of retail outlets is, when number of retail outlets increases by 1 unit, on average, you can choose not to bring the on average. On average, what's the independent variable here? Regional sales. Regional sales will regional sales will decrease by 0.006 units, all things being equal.
So where did you get the original sales from?
So pay attention. When number of X1 stands for what? Number of retail outlets. When it increases by 1 unit, on average, regional sales. So when each of these dependent variables changes, regional sales will also be changing by the coefficient multiplying them. So here B1 is the coefficient of 1 for X1. What is the coefficient of 1? This is negative 0.006. That's what I wrote here. That's the B1. The B1 is also up here. Watch, this is the B1. So this B1 here, this is here. And that is what I've also written on the left. So that figure, the same figure, if it's positive, I written positive, is negative, I write negative. So when the number of retail outlets is the X1, it was always going to increase by 1 unit. Let's assume that. On average, then regional sales the coefficient, is it negative or positive figure? It's negative. So regional sales will decrease by that number of units. So when you say decrease, don't bring the negative again. All things being equal. Are you good?
Yes, sir.
Good. Are we good?
Yes, sir.
Now let's go. B2. Beta coefficient 2. What's the value? What's the value for beta coefficient 2?
1.739.
That's 17 minutes. So B2, watch. What's the coefficient for B2? 1.7399, right? Because it is multiplying the x2. So B2 is the coefficient here. So we say 1 is positive. So I will maintain it 1.7399. Then we will say. So if I'm going to interpret, look at the B1. What I have underlined under the B1, those are what will change. If what I haven't underlined won't change. What I have underlined under the B1, they will change when I'm interpreting the B2. Those I haven't underlined, they will not change. So I'm going to do the B2. So B2, when or if. What is X2? What stands for X2 here? Number of automobiles registered. So when or if number of automobiles registered increases by 1 unit on average, regional sales will, here it is positive, the B2 is positive, so will increase by 1.7399 units, all things being equal. Do we get it?
Yes, sir.
Yes, sir.
So just copy what, if you're able to state the first one, the second one, you just change those I've underlined because you change them. But those I haven't underlined, they will be the same. So when I've underlined number of retailers, the meaning to change. So you place in the X2. Number of automobiles, don't change all those I haven't underlined. Increases by 1 unit on average. Regional sales will, you come and check the B2, is it positive or negative? Here it was negative. That's why we use decrease. But here it's positive. So regional sales will increase by, here it was 0.006. But here it's 1.739. So to change, 1.7399 units, all things being equal. You do the same for B3. You do the same for B4. You do the same for what? B5. That's the interpretation. I'm done. Are we good?
Yes, sir.
Yes,
Class,
sir.
are we good?
Yes,
Yes,
sir.
sir.
So I'm done with question 1. I'm done with question 2. Let's go to question 3. test at the 5% level of significance, the multiple linear regression model. When the question says you should test the model, it means that it wants you to make use of this F and significance F, meaning you are testing for the entire model. So you're going to make use of one of these. I always like using the significance F because I will not use a table. It's easier. So to test, we will first state the hypothesis. Say the what? Hypothesis. We will just say 1. The 5 we learned under one sample teacher, we're going to use it here. We just say 1. What is it? State the hypothesis. So that's the first step. Now hypothesis, we can say Bj is equal to what? 0, meaning no relationship. Yeah, using it a different way. H1 is the alternative. Bj, when I use Bj, I'm trying to mean, let me simply say, I'm referring to all the whole model. It's not equal to 1. Meaning what? There is a relationship. In other words, or I can say that Bj is equal to 0. I'll say insignificant. Use the insignificant rather. Don't use the no relationship. So if it's equal to 0, insignificant. Let me put it that way. If it's equal to 1, significant. So there's a relationship. Let me put it that way. So what is the significance level? At the 5% significance level. At the 5% significance level. That's step 1. Step 2. What is that step 2? Decision rule. We said what? HD can do conclusion, right? So I've done the hypothesis.
Yeah.
I'm doing the decision rule. Decision rule. Decision rule, we will take the significance F. What is the significance F? 0.1231, right?
0.
Right?
No,
0.0001.
0.0001.
Then
Yeah.
we'll say if the T cal, or I can say if the significance F, which is up there, is more than the significance level, which is 0.05, reject HO, retain H1. Then if the significance F, this one I'm using a long process, is less than 0.05, reject H1. Retain HO. Reject HO. Retain. Okay, hold on. I've just swapped it. Reject HO. If it is less than it. Okay. It is, I've changed it. Let me make it this way. If it is less than 0.05, reject HO, retain H1. If it is more than it, reject H1, reject H1, retain HO. Yeah, this I should be. Are you good? I'm writing
Yeah.
all this. It depends on what the marks for C would say. It depends on what the marks on C will say. If the marks of C is 5 marks, then I'll state all the 5. So I'll get 5 marks for all the 5 steps. If the marks for C is 1 or 2, don't do all the 5 steps. Just write here. Just start from the decision rule and go down. Okay. So what is the first step? HD can do conclusion. So I'll do computation. Yeah, I'll not say any computation. I get it. What is the significance F? Is it 0.01?
Yeah, 0.0001.
Yeah, so I'll write here significance F. What is significance F? 0.001. That's all my computation. I'm at 4. Can do. So I'll make the decision here. So the significance F, is it less than or more than the significance level? So this is the significance, this
More
is the
than.
significance level. This is the significance F. So 0 cancels 0, 0 cancels 0. This is 5, this is 0. Is the significance F more or less than is the significance F more or less than the significance level? Is it more or less?
It's more.
So this is 0, cancels 0. This is 0, it cancels 0. This is 0, this is 5. So which one is greater, 0.05 or 0.001?
0.05.
So we say the 0.001 is less than the 0.05. So the two decisions, which one do we go for, the first or the second? Decision rule, which one do we go for, the first or the second? This is the significance F. This is the significance level. So is the significance F less than or more than? It is less than. If it is less than, we will go for the first option. Do we get it?
Yes, yes.
Class, do we get it?
Yes, sir.
It's very, very easy. It's not difficult. It's very, very easy. If you go and use the table, the tabular one, you have to go and use the format, but this is okay. So decision, we will say that as, just like the first one, as the significance F, I'm recopying what the decision rule is. As the significance F is less than 0.05, right? As the significance F is less than 0.05, what do we do? Reject HO and do what? Retain what? H1. What is the conclusion? If you are rejecting the HO, what is H1 saying? H1 says what? It is not equal to, sorry. What? Let me clean this. This is 0, okay? This is 0. Because we said it should be the opposite side. So if this is 0, this is not equal to 0. So what is the H1? It says we should reject the HO, meaning this one, we shouldn't take this one into consideration. We should take the H1. What is the H1 saying? Significance, right? So conclusion, at a 5% level of significance, it can be concluded that the multiple linear regression model is what? Is significant. Do you get it?
Yes, sir.
In exams, if they say the question, the C is 2 marks, just start from the 4 and end at 5. So you say, as the significance F is less than 0.005, reject H or return H1, then you conclude at a 5% level of significance, it can be concluded that the multiple linear regression model is what? Significant. Are we okay?
Yes, sir.
Okay. So I'll take if the question says that question gives me 5 marks, you have to go through all the 5 steps. Are you good? Now we are done with C. We are done with C. Let's be quick. Now let's do E. Hey, I have enough. Okay, let's do E quickly. E says, no, sorry, D. I want to finish on time. State with reasons which of the independent variables are statistically significant at 0.05. Would you consider eliminating outlets? Would you consider eliminating outlets and bosses? Okay, the bosses are the supervisors, I guess, yeah. So it says state the reasons which of the independent variables, you don't include intercept. Intercept is not an independent variable, it's a constant, so you don't include it. So what you start is you write this independent variables, a table. Then you write all of them, x1, x2, x3, x4, x5. Then you come with another table. You write here their p-values. Okay? You write their p-values. When you write their p-values, what is the p-value for x1? 0.0222. I'm taking the figures from here. Here. Then x2, what is it? 0.8234. x3, 0.0346. x4, 0.0007. Hey, wait, I made a mistake. Hold on. So x1, the intercept p-value is not par. So it's going to be 0.8234. Then 0.0346. Then 0.12307. 0.0812. Then we have 0.8635. That's the p-value. Then after we get the p-value here, we will now write here significance level. Significance what? Level. Or you can just write alpha level. Everyone or anyone who takes the document to understand alpha level. What is our alpha level? 0.05, 0.05, 0.05, 0.05, 0.05. Then you write here decision. You just say, okay, so you write a decision rule, then write a conclusion. So what is our decision rule? Let's just write it. What is our decision rule? Here, our decision rule will be that if p-value is less than 0.05, reject HO. Retain what? H1. Then if p-value is more than 0.05, reject H1. Retain HO. So we are just going to compare all the p-values for each of the independent variables against 0.05. Is it more or less? If it is more or less, decision, we will say reject. Reject HO. Retain H1. Reject. That's what we are going to do. We get it?
Yes, sir.
Okay, so the first one, is the x1 more or less than the 0.05? So
It's
this is
more.
0, this is 0, this is 8, this is 0. So it is greater than, right? So if it
Right.
is greater than, do we reject H1 and retain HO? Class,
You
if it's
reject
greater
it.
than,
Yes.
we reject H1 and what? So you write, reject
Retain.
H1. If we reject H1, it means we retain HO, right?
Yes.
The next one, this is 0, this is 0, this is 0, this is 0, this is 3, this is 5. Is it less or more?
It's more.
Is it
Hey,
less?
no,
Is the p-value less than or more than the alpha level?
it's less than.
It's less because 0 here, 0 there, 0 there, 0 then 3, 5. So when it is less, what do we say? Reject HO. So if you reject H1, it means it is insignificant. Are you getting it?
Yes, sir.
Because we said HO is what? Insignificant. And H1 is significant. So if you are rejecting the H1, it means that HO is what you are accepting. And HO is insignificant. The second one, we reject what? HO. When we reject HO, what do we retain? H1. So it is significant. The third one, is it more or less?
The, um,
The third one, is it more or less than it?
less.
Less. So what do we do? We reject HO. When we reject HO, what's the conclusion? Significant. H, what's the name? X4. Is it more or less? This is 8, this is
More.
5, this is 0, this is 0. It's more. So reject what? H1. What is H1? Insignificant. The fifth one, more or less?
More.
More. So we reject what? H1, insignificant. And the question says, would you consider eliminating outlets and boxes? What are the outlets? Outlet is what? Variable 2, right? Here.
Yeah.
And bosses are who? Supervisors. So would you consider eliminating outlets and bosses? So for bosses, which is the X2, no. But for the for the outlet, which is significant, it's a no. You don't eliminate it. Wait. Oh, sorry. The outlet is X1. X1 is the outlet, which is 0.8. So that one is insignificant. And the X5 is the supervisor, sorry, right? So the X5 is also what? Insignificant. So would you consider eliminating outlets and bosses? Yes. Yes, I would consider eliminating outlets and bosses because they are what? Insignificant. Are we good?
Okay.
Are we good?
Yes. Okay.
So we are on E. E says, what is the expected total sales in a region with 2,000 outlets having 12,000 automobiles with total personal income level of $25 billion, where the average age of automobiles is what, 3 years and 12 sales supervisors. So I'm saying you just copy the original sales model. But when you are copying it, you are going to replace the X1, X2 with the corresponding figures here. Are you good? You're going to replace the X1, X2 with the corresponding figures here. That is what you're going to do. So regional sales model or regional sales equals the negative 196715, right? Then minus 0.0006. What is the value for X1? The outlets, 2000, right? Then plus 1.7399. X2, I'll not write X2. I'll multiply it by the 12,000. So let me just use 12,000 here. Automobiles plus 0.4099 X4 times X4. I'll not bring the X4. I'd rather write 25 billion. So I'd rather write 25,000. Okay, why am I writing 25,000? Because the outlet is 2,000. So I'm just reducing all the other figures to 1,000. If the thousands or if they are exceeding 1,000, like they are millions or billions, I'm just writing the thousands, putting them in thousands. Then I have
So that how
plus,
supposed to use.
yeah, you can write it that way. This is all correct. 2.0357 multiplied by X5. What is X5? X5 is 3 years, minus 0.0344 multiplied by X5. What is the X5? It's 12. So when you add all these together, right, that will give you your estimated regional sales. That's the final answer. Are you good? You add and subtract all the figures from here. Add all of them. What I've just done. You write the sales model and plug in, replace the X1 and to X5, all of them with values. Then that'll be your final answer. Let's go to F. What is the coefficient of determinant? Interpret your answer. So the coefficient of determinant is this R squared. This R squared. So you write here R squared equals what? 0.9943 multiplied by 100%. You have what? 99.43%. Then you say that 99.43% of the variation in regional sales. Regional sales, don't forget in the equation, it is the independent variable. 99.40% of the variation in regional sales is attributable to or is caused by the variation in all the independent variables. What are the independent variables? The X1, so we write they are long. The X1, X2, X3, X4, and what? X5. You don't write X1, X2, you write them in full. You write them in full. So what is X1? Number of retail outlets, you write it in full. X2, number of automobiles registered, comma, personal income, comma, average age of automobiles, comma, X4, and X5 is what? Numbers, right? So you write them in words, in full. Don't write X1, X1, X2, X3, X4, X5. I just want to finish up quickly. So that's why I wrote them in X1, X2, X3, X4, X5. In writing, write them in full. Pick the R squared, multiply by 100%. Then you just say 99.43% of the variation in regional sales is caused by the variation in what? X1 to X5. Are you good?
Yes.
Yes,
Right.
please.
Let's go to G. What percentage of the total variation in sales can be attributed to other factors apart from these five? The five are it is called coefficient of non-determination. Coefficient of non-determination. Simply put, you say 1 minus R squared. Are you getting it? What is 1 minus R squared? 1. What is R squared? 0.9943. What do you have? 0.0057. Is that correct? Is that correct? Quick. My
Yes,
time is up.
yes, that's correct.
So you multiply this by what? 100%. What do you have?
0.57.
So we say that 0.57% of the variation in regional sales, right? We can say is caused by, or we can say is explained by by other factors, apart from X1, X2, X3, X4, and what? X5. Do you get it?
Yes.
That is called coefficient of non-determination, meaning there are certain other factors which were not considered in the analysis, in the study. Those other factors contribute to what? 0.57% of the changes in regional sales. Are we okay?
Yes.
Class, are we okay?
Yes, sir.
Good. So we have ended. I will record, I'll upload it and I'll send it to you.